Good afternoon. Welcome to class. I just wanted to go over lesson 1 in Unit 10. I hope everyone had a great weekend and is working hard to complete Unit 9 and test on it this week. So let's begin Unit 10, Lesson 1. It's about uh, triangles and being similar. It's called Similar Triangles. This is from page 861. So the problems that we're going to be looking at in the guided practice are on page 866. So we have, for problem 1, two triangles. They're both right triangles. And the problem wants us to determine if that triangle is similar. And if it is similar, it wants us to write a similarity statement. And so what we want to do for this type of problem, whenever you see a right triangle, definitely want to do this step. We're looking at the ratios. We're going to be looking at the different ratios to see if they are the same. Meaning if the fractions of one triangle, like a ratio of the side lengths, is equal to the ratio of the other side lengths, then it will be a similar triangle. So if we look at MP, we're just going to write that. What I mean is MP, side MP over PN should equal basically the smaller side, so SR over ST. So MP is 5 over 15. Does that equal SR over ST, which is 7 over 20? Well, looking at 5/15, if we divide 5/15 by 5 over 5, that's going to give us 1/3. Does 1/3 equal 7 over 20? Can we reduce 7 over 20? And we cannot. So this, for problem 1, is not similar. And it's because 1/3 does not equal, I'm going to say does not equal 7 over 20. All right. So what I was going to show you that I wrote up here is, besides looking at side lengths for ratios, for the similarity statements, if it is a similar triangle, we have to write what is known as similarity statements. And these statements are 3 things that we have looked at, or 3 types of ways that we've looked at to prove that triangles are similar or congruent to one another. And that's angle, angle, side, 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 and side, angle, side. So those are the 3 types of similarity statements that we are going to look at. Angle, angle, side, 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 and side, angle, side. So the next problem wants us to know if triangle ABC is similar to CDE. And if you notice, we have these 2 arrows down at the bottom, meaning that these 2 lines are parallel to each other. So if we remember, 2 parallel lines, they're going to create angles that are similar, or I mean angles that are congruent, and that's alternate interior angles, because we have 2 parallel lines, and the lines that basically connect from one parallel line to the other, it creates alternate interior angles. And then also, if you look, these 2 angles are what's known as vertical angles, and so they're similar. So we have a bunch of congruent angles. So this would be congruent because of an angle and an angle. So in this case, we do have similar triangles. And the way we write a similarity statement is triangle ABC is similar. So instead of doing a congruent sign, we don't know if it's the same size for each of the angles. We know that the ratios are similar, and we don't know if the side lengths are the same. So the similar symbol is one squiggly line. And then we're going to say triangle ABC is similar to triangle, I'll just say DCE. And it's because of angle, angle. All right. So it's by angle, angle. So that is the first two problems. I will let you write them down. And then we will move on to the next problem. All right. So let's move on to problem 3. So problem 3 states we want to, again, determine whether these triangles are similar. If so, write a similarity statement. So we have a triangle F, G, and H, and it's 3, 13, and 9. And then we have this other triangle, K, L, and J, and it's 5, 22, and 15. So what we're going to do is look at these triangles and see if we have a ratio. So let's look at the first two sides, F and G. So we're going to say F and G over GH. Does that equal, well, this is the smallest side length and the second smallest side length. So we're going to go 5 and 15. Does it equal KJ over JL? That's the question. And so we're going to go the ratio 3 over 9. Does that equal 5 over 15? And that is actually 1/3 does equal 1/3. So it is basically these two side lengths are similar because they have a 1/3 ratio. However, we're looking for angle, 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 side, 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 or side, angle, side. So since we're not given an angle, we have to test the ratio of the last basically side as well. So we're going to now have GH, again, this side over FH. Does that equal JL over KL? That's the next question. So GH, again, is 9 over FH, which is 13. Does that ratio equal 15 over 22? Can we reduce 15 and create 9 or like 3? So if we were to divide 9 and 13ths can't be reduced and 15 over 22 can't be reduced. So these do not equal each other. So because the ratio of these two side lengths or the ratio of those two side lengths do not equal each other, this is going to be not similar. So remember, you have to test for similarity using angle, angle, side, 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 or side, angle, side or similarity statements. All right, so let's move on to problem number 6. So problem 6 is it says identify the similar triangles, find each measurement. So we have, it's like a smaller triangle connected to a larger triangle. So we have triangle A, B, C, D, and E. So we have A, B, E, and triangle A, C, D. And it says that these are parallel. That's why it has the lines that are drawn like that. And EB is equal to 5. And X is down here. And it says that the height from D all the way to A is 7. And now it wants you to identify the similar triangles. So let's first identify. Well, we know that ABE, so triangle ABE is similar to triangle ACD. And what it wants us to know is find each measure. So this is the similarity statement. This smaller triangle right here is similar to the large triangle. Okay, however, we need to find x. We don't know what x is. So essentially, what we are going to do is set up the problem. I want to look to see if there's an example that I can give you to look at beyond this problem. And we are missing a piece right here. Essentially, AE is equal to 3. All right, so what we are going to do is set up a ratio, just like we have on another problem. I believe example 4 on page 864 shows you how to do this. And what we are going to do is set up a ratio because these triangles are similar. So we are going to do, let's do this side AE. So side AE over AD equals EB over X, or DC, sorry. So what we're doing is this side length, AE over AD, the whole entire larger triangle side length, is equal to EB over DC. So now we're just going to plug it in. So AE is 3. AD is the entire side length. So how high is that entire side length? That is the question. And what we're going to do, I guess, is label it as 7. We're going to see if that works. And then what we are going to do is have EB, which is over 5, and DC, which is X. And to solve for X, we have it's called a proportion. We're going to just cross multiply, and we're going to have 3x equals 35. Solving for x, we're going to divide both sides by 3. X equals 35 divided by 3. So that is the solution for x. So this is number 6 of the guided practice, and we are now going to move to